Okay, so, oh, it's very clean now. Perfect. Wow. Okay, so we go now to stoichiometric chemical calculations. Oh, diba? So it's gonna be, okay. So, question number one. Okay. Question number one, mga palangga. So it's gonna be, okay, what mass of oxygen gas will be required to react exactly with 96.1 grams of propane? So this is all about stoichiometric chemical calculations, right? Okay, so how can we do this? Oh my gosh. Stoichiometric chemical calculations, there's no standard equations and formulas to be used because you always use the dimensional conversion way of solving, longhand way of solving, something like that. And all you have to do is to play around with your analysis and the problem solving, something like that. Okay, now mass of oxygen is required. So required, okay, mass of oxygen, say grams of oxygen, grams of oxygen. Okay? Question mark. Ganon. To react exactly with 96 grams of propane. So you will start with our chemical reaction will be our Xn is equal to oxygen gas react with, okay, so CO2, okay, like that. Again, we're still research. Okay. Sorry. Okay. Oxygen gas is required to react with propane. So, okay, oxygen gas plus C3H8, right? And this is combustion reaction, right? This is the propane and this is the oxygen gas, mga palangga. Okay, so it will become now carbon dioxide plus water and then balance the chemical reaction. It is combustion chemical reaction, right? So it's going to be carbon 3 and then we did have carbon here, something like that. So let's put 3. I use trial and error method. Okay, first, let's see if I can easily balance the chemical equation. Okay? But actually I don't like, I just prefer to use the algebraic expression balancing of chemical equations, but I will try. Let's see. So carbon 3 like this, and then hydrogen 8, so it's going to be oxygen 6. Hydrogen 8 is going to be 4, right? So oxygen 6 plus 4, 10. And I have to put 5 here. Oxygen 10, 4 plus 6, 10. Carbon 3, hydrogen 8, right? So this is balanced through trial and error method. Okay, let's check again. Oxygen 10, 6 plus 4, 10. Hydrogen 8, carbon 3, balanced by trial and error method. Okay, this is now completely balanced. This is our chemical reaction or stoichiometric chemical reactions. So you will base your calculations here. Okay, and then we have the basis of calculation. We have 96.1 grams of propane, something like that. Okay, so you need to compute for the grams of oxygen gas. So we have here start with 96 grams of propane. So 96.1 grams of C3H8. Take the gram mole for this. Molecular weight of the molar mass. It's gonna be, okay, carbon 3 times 12 is equals to 36, right? And then for hydrogen, we have 8 times 1.008. How much? Calculator please. Okay. How much is this, mga palangga? So it's gonna be 8 times 1.008 is equals to 8.064. So 8.064 plus 36. Okay? Plus 36 is equal to 8.064 plus 36. 44.064. 44 0.064 grams per mole is the molar mass or the molecular weight of propane. More or less the same with carbon dioxide, right? 44. I'm correct, right? Carbon dioxide is also more or less 44. Okay, but never mind. Okay, we're concentrating with the propane. Okay, so 96 gram of propane times this one. 44.064 grams mole of propane. These are all propane. Guys, so the grams. Okay, now you have the mole here. That consider the stoichiometric relationship in your step number 2. So we have 1 mole of propane, 1 mole of C3H8. How many moles of oxygen gas? Because the oxygen gas is being asked. So 5 moles of oxygen gas. Now, since you are looking for the mass, carry and multiply it with the molecular weight. It's going to be oxygen gas 32, right? 32, 16 times 2, right? 32 grams per mole of oxygen gas. And we have now the grams of oxygen gas because the moles will be cancelled. How much is this? Calculator, please. Okay. 5. Okay. 5 times 32 yes, times 96.1, yeah, okay, divided by 44 that's 06 equals to, we have 348.98 grams of oxygen gas. This is our answer. What mass of oxygen gas would be required to react exactly with 96.1 grams of propane? Our answer will be 348.98 grams of oxygen, something like that. Okay? Now, if you need to ask the other, you can solve also. As long as we have the stoichiometric chemical calculations, bingo, we can solve for others also. Now, in this particular kind of problem, guys, you need to add also the terms such as limiting reactant and excess reactant. Okay, all the time like this in stoichiometric chemical calculations, limiting reactant and the excess reactant. So LR, limiting reactant and the excess reactant. Okay, excess reactant. Okay, since the limiting reactant is our basis to compute for the desired ratio, mole to gram to mole, like that, and whatever, we will base always in the limiting reactant. Okay, so how can we solve for the limiting reactant? So solve individually the number of moles of oxygen gas and propane, because your reactants here are propane and oxygen gas. So one among them is a limiting reactant or either an excess reactant. Okay. Now, this kind of terminologies will be applicable to our percentage. Okay, yield. Okay, percentage yield or percentage output in this kind of chemical reaction as opposed to the actual yield over theoretical yield. Okay, theoretical yield, times 100. Okay, remember guys that this formula also will be equated or the same as in the principles of the mechanical advantage in physics. That states percentage efficiency, the word always being changed. The yield, instead of yield, it's efficiency. Is equal to the work output over the work input times 100. It's just the same thing in physics. And then also, it's the same thing in the, wait for a while, in second law of thermodynamics. Okay, percentage output will be equal also to the output temperature over the input temperature times 100. Or it could be also the heat output over the heat input times 100. Okay, if you talk about things like this, percentage yield, percentage efficiency, like that, or you can say percentage, efficiency, or like that. It's also noted as work output over work input times 100. Okay, and then heat output over heat input times 100, or temperature output, temperature input times 100, or temperature final over temperature input over 100. It's gonna be like that in the Sally-Carnot principle in the heat engine. Okay, like that. Thermodynamics. Second law, I think so. Okay, because the first law will be more on the calorimetry, and the second will be more on the heat engine, combustion heat engine cycle. Okay, something like by Mr. Sally Carnot. Okay, in thermodynamics. I also read this also there. Okay, what I'm telling you is just like that. We need only to change the word. Okay, from yield you need to put efficiency only. Okay, it's gonna be like that. Okay, now how can we do this for this particular problem? Then we can have a backup question like this. What is the percentage yield of, let's say, oxygen, or like that? No, carbon dioxide, because your yield will be carbon dioxide and water, right? Yield talks about the result, the product, the impact, like that. And your products will be carbon dioxide and water one shot. So it will say, what is your percentage yield of carbon dioxide and water, something like that. Okay? Now, in this case, we need to compute the limiting reactant and the existing reactant just to prove which among them is the limiting reactant. Okay? Because we cannot guess. Okay? Something like that. We cannot guess mga palangga. So if you have 300, what's this? 408.898 grams of oxygen gas. Compute for the number of moles for this. So 32, okay, 32 grams per mole, then the mole of oxygen gas will be divided by 32. Okay. This is gonna be 10.91. 10.91 moles of oxygen gas. Okay? Now, since we have the original number of moles of oxygen gas in the reactant, which is 5, divided by this 5 mole. Because that is the ratio. In determining the limiting reactant, that is the ratio of the number of moles, final and initial. So we have 5 moles of oxygen gas in your initial chemical reaction, cancel the mole, and then 10.21 divided by 5, you got 2.18. So consider the number of moles which is very, very less, and that is your limiting reactant. So this is 2.18 moles of oxygen. So how about the propane? Okay, your initial mole of propane is 1 mole based on the chemical reaction. Okay, initial. Okay, and now your final. How can you do that? X, unknown. So you will use either this 2.18 or 34898, or use the 96.1 grams. You have 3 bases of calculation if you like, as long as you can get the final number of moles of propane, something like that. But di na lang tayo lalayo because this is propane, right? Go with the propane, not for the oxygen. What I'm trying to emphasize is that even though you will start at propane to compute for the number of moles of propane, you can still use oxygen gas. It doesn't matter because that is relating to our stoichiometric chemical equation. Okay, so use 96 gram of propane. So 96.1 gram of propane. Okay, like that. Okay, and then how many gramos or molecular weight of propane? So we have, 44 to siya. So 44.064 grams of propane mole, and then cancels how many propane. Okay, for this. So 96, okay, like that. Okay, 96.1. Okay, like that. Okay, you can do this, guys. Let's check. Okay, 96.1 divided by 44.06. So we have 2.18. Okay, the same also. Okay, 2.18. Okay, and then 2.18 divided by 1. So it's equals to 2.18. This is your option number 1. Then, since you have equal number of moles, okay, then it's not valid because one of them should have at least the minimum or the least. So meaning your analysis is wrong. So you could either use in terms of the oxygen that we get or we cut. So you cannot use the 96 gram of propane directly if we get the final moles of propane because our answer will be just the same with the oxygen gas, which impossible. Okay? You get the point? So, or else there will be no limiting reactant if that is the case. So the theory speaks that your answer is wrong. So you go to the oxygen, which is 2.18 moles. Okay, so 2.18 moles of oxygen, okay, then check your chemical reactions, okay, so 5 moles of oxygen gas, and you have 1 mole of propane, okay, so what is the answer? Mole of propane. So 2.18 divided by, diba, 5. So you have 0.436, right? 2.18 divided by 5, you have 0.436 mole of propane, okay, like that. Then the original of propane is only 1. So, divided by 1. So, you have 0.436 propane. 0.436 mole of propane compared to the 2.18 moles of oxygen gas. So, therefore, our limiting reactant is propane. This is the LR. And the ER, this reactant is oxygen. Now, prove that again using ratio and proportion. Okay? This is through calculation and we will use ratio and proportion. Okay? Now, things like this. Okay? If we have 2.18 moles, the final of moles of oxygen, so let's say 2.18. Ganon. And initially, we have 5 moles of oxygen in the chemical reaction, and the ratio and proportion also with propane. So, our initial propane is 1 mole. Then solve for the value of X, the unknown moles of propane, in the final chemical reaction. So by math, 5 over 1 is equal to 2.18 over X. Then 2.18 divided by 5, right? So 5 over 1, yep. And 2.18 over, X, in which you don't know, right? Okay, let's check. Okay, it is really valid. Okay, 2.18 divided by 5. Yes, equals to 0.436 moles of propane, both in the ratio and proportion method and in the stoichiometric chemical calculation to solve the number of moles of propane is just the same. So 0.436 is the ratio. This is ratio meaning no unit already, na? Okay? There's no unit with this ratio. 2.18 lang din siyang mapalangga. Okay? Ganon. So, 0.436. Okay, so our existing reactant is oxygen gas and our limiting reactant is oxygen gas. In this case, how can we go with the percentage yield? So, what's it? Percentage yield of oxygen. Percentage yield of oxygen is equals to the moles of oxygen in the final that we get, which is the 10.91. Right? 10.91. Okay, and then actual yield over the theoretical, which is the 5, right? Am I correct? So it's gonna be like that. So actual minus theoretical. Okay, it's gonna be 2, right? 10.91. 10.91 divided by 2. Okay, it's gonna 5.45. The actual yield for propane also, we need the actual. So, pila na ito makunod ato niya sa propane. Diba? If you have the 2.18, how much the propane? So, you have also 0.436, right? Okay. Or you can solve directly. Okay, like that. So, how many? So, 0.436, ganon, over theoretical na 1. So, 0.436 times 100. 43.6, right? 43.6%. The propane. Okay, like that. And then, if we have 43.6 propane, since we add this one, so X plus Y is equals to 100%. Right? In math also. Ako na ni siya guys ha. So X plus Y is equals to 100%. In math na ni siya. And then, we need to compute for the percent of oxygen is X, okay, plus Y. And then our value of Y is 43.6% for propane, in which we get, right? So plus 43.6%, then you minus mo ang 100, therefore X is equals to 100 minus 43.6 is equals to 56.4%. Our, okay, actual yield of oxygen. Percent oxygen actual yield, and 43.6 actual yield of propane. Okay, ganon siya. Okay? Get the point mga palangga? Okay? Ganon. Okay? Okay mga palangga? So that is the value. Okay? Ganon siya. Okay? You get the point? Wala siya. So any questions so far for this? Okay mga palangga. Kung hitad. Charot. Okay? Okay mga palangga. Any questions so far? Muna siya, inaon siya guys ha. Okay, thank you so much for watching. You can like and comment this video if you want something like that. And then you can comment down below. You can subscribe to the channel and you can share this video to anybody else. And then you can subscribe to the channel if you want. Also, bye-bye. God bless everybody. Diba? Ganoon. Okay.